Hi, today's lesson is about chromatography. This is a practical that you should have done earlier this year. Our challenge for today is to describe the method for carrying out chromatography, and our aspire is to be able to interpret and make conclusions from simple chromatograms. First of all then, to get started, 2 questions. What is a pure substance, and how can we determine whether a substance is pure or a mixture? I'm going to give you 1 minute to think about that.
Okay, so pure substance is made of only one type of element or compound. And the way that this differs from a mixture is a pure substance will have a fixed melting and boiling point, whereas a mixture will melt and boil over a range of temperatures.
Okay, so just a bit of a jogging memory about looking at this practical. Can you remember what generally it was about? And what would be labels for A, B and C? You need 30 seconds to think about that one.
Okay, so generally this practical is about separating a mixture. Often in the examples you will have seen this will be a mixture of colours, be that inks or be that food colourings or perhaps colours of flowers. A would be the chromatography paper. B would be the pencil line, and it's really important that this is drawn in pencil. And C would be the solvent.
So the first thing we do is we draw a line in pencil near the bottom of the paper. We always draw this in pencil because if we draw it in ink, then the ink will also run. Next, you would put a sample of the unknown substance. So we just put a dot, and in this case we've labelled it X. Then we will put dots of the substances that we are going to compare it to, so known things. So this example is using food dyes, and we know what food dyes A, B, C and D are. And the purpose of this is to find out which of the dyes A, B and C are contained in X. Right, next we put the paper into the solvent, making sure that the solvent is below the pencil line. We don't want to just wash off the dots that we've just put on. Now the solvent will travel up the paper, This is called the mobile phase because it's moving. And as it travels up the paper, different spots will have different solubilities. Things that are very soluble in the solvent will move very far. So in this case, the green is very, very soluble. And things that are not very soluble in the solvent will not move as far. So blue is not very soluble. We then use these to compare from X which of A, B, C and D are in X. So we take out the chromatography paper and we leave it to dry. Now, from this one, we could make a number of conclusions. The first one would be that X contains 4 different substances. We can also compare them and say of the 4 different substances, one of them was A, one of them was C, and one of them was B. We can also say that X contains something that we don't know what it is, and in this case that will be the pink splodge. We don't know what that is. And we can say that it absolutely doesn't contain any of D. So, here's one I made at home. Now, I didn't have any filter paper at home, so I used a coffee filter. So you could do this. You could buy some coffee filters from the supermarket. And I drew my pencil line with a ruler. And then I used some felt pens. And I drew a dot with a red pen. I then drew a dot with a blue pen. And I drew a dot with a purple pen because I thought, well, purple, we make it from blue and red. I then put the piece of filter paper in some water, about 50 millilitres of water, but if you didn't have a beaker with a measurement on it, it's about 1 finger depth. And then to suspend the filter paper in the water, I just attached it to a straw with a paper clip, but you could have equally used a ruler or anything else that was straight. And just by doing that, it allows it to dangle along the top. You can see I put the paper in so that the water was below the dots, and then we allowed the solvent to rise up the filter paper and the colours start to separate out. So remember again, the solvent, in this case water, is the mobile phase because it moves. The filter paper will be the stationary phase because it doesn't move. Things that move a long way up the filter paper are very soluble in the solvent. And that's why they move further. So in the mobile phase, they are very soluble. Things that are not as soluble in the mobile phase will not move as far up the paper. They may have a greater attraction for the stationary phase. And then I came back to it. What I want you to do now is I would like you to pull up your Google Doc, slightly shorter one this time because we're not going to look at the variables, the independent and the dependent variables, but you should be able to list the apparatus that you would use and draw a diagram of how it was set up. And then step by step, I want you to write your method, and we're going to give you 10 minutes to do this.
Okay, let's go back to the one that we started earlier. Here you can see that the solvent has got quite close to the top of the paper now. So we take it out and we put it down to dry. At this point, we should also make a line with pencil next to where the solvent finished. Now looking at this one, we can see some interesting results. The red that we thought would be used to make up purple isn't there. But the blue is, and we can see that the purple did contain some blue, but it didn't contain any red. So what I would like you to do now, go back to your Google Doc and fill in the results and see if you can explain why this happened. I'm going to give you 4 minutes to do that. Okay, so just to reiterate a couple of things before we move on. First of all, to remember that the stationary phase is the chromatography paper, and that is absorbent. But the mobile phase is the solvent. It's the bit that moves.
Right, so we take some measurements with these, and it's called the retention factor, or the RF value. And the way that we work this out is that we measure the distance travelled by the substance, and we divide it by the distance travelled by the solvent. RF values vary, and they will be specific for each substance, but they will always be between 0 and 1. Here's an example. So I've got my baseline, where they started, and where the solvent finished. Remember, we marked that as we finished, and also the distance travelled by the spot. Okay, so here I've just used a clearer version of the red, the blue, and the purple. So just a reminder then that the RF value is the distance travelled by the substance divided by the distance travelled by the solvent. Now, in an exam, you might well be expected to measure this with your ruler. I always find it easier to do the solvent front first, so that is all the way from the pencil line to the point that we marked as we took it out of the solvent. And in this case, it's 10 centimetres. Then we look at the distance travelled by the spot, and again, we're measuring this from the pencil line, usually to the centre of the spot. This one's 5 centimetres. This means our RF value in this case is 0.5. Notice it doesn't have any units because the centimetres cancel out. They're on the top and the bottom. It's just a ratio. And the RF value will always be less than 1. It can't be more than 1 because that would mean that your spot had travelled further than your solvent. 2 marks in the exam, 1 for doing the sum and 1 for getting the right answer. Okay, you're going to have a go at doing one now. So I'd like you to calculate the retention factor for the green dot. All the measurements are on the diagram. And I'm going to give you 2 minutes to do this. Off you go. Okay, how did you get on then? So, in this case, the RF value would be the distance travelled by the substance, 8 centimetres, the green dot had travelled 8 centimetres, divided by the distance travelled by the solvent from 12 centimetres. When we divide these numbers, we get an answer of 0.666 recurring. It asked for the answer to 2 decimal places, so we look at the first 2 decimal places and we find it's 66, and then we look at the decimal place to the right, and that is above 5, so we round our second decimal place from 6 to 7. So we get an answer of 0.67. Right, so on your Google Doc now, you will find that you have got an exam question. We'd like you to have a go at doing the exam question, and then
once you have completed the exam question,
we would like
you
both the exam question.
We would like you to hand in your method, your conclusion, and your exam question to your teacher, and they can then mark it for you and give it back to you with some feedback. Well done, everybody.